10, 11, 12, solving a trigonometric equation involving a squared function. These ones we're going to solve by factoring them out. Again, oops, I'm going to want to have my table so that when I'm done solving for sine, cosine, tangent, whatever it may be, I can look up my values from my table. So I want to make sure I have my table handy. Going back over here then to number 10, because my board moved. So number 10, we have 2 cosine squared of x minus 7 cosine of x plus 3. You can think of this without the word cosine in there. If I had 2x squared minus 7x plus 3 and I wanted to solve that, how would I factor it out? Well, I'm going to have my 2 sets of parentheses. For 2x squared, I'd have to have 2x times x. So I would have 2 times the cosine of x times the cosine of x. 2 cosine of x times cosine of x is 2 cosine squared of x. Since the end is positive, both signs are the same as the middle, negative and a negative, I want the factors of 3, so I add up to the 7. So I'm going to have to take my 3 times my 1. So 2 cosine of x times minus 3 would be minus 6 cosine of x, minus 1 cosine of x in the middle. Negative 6 minus 1 is negative 7, so I have it factored out. But if you're not sure, factor it without the word cosine and say, okay, x and x, a minus and a minus. Oops, no, I'd have to have 2x and x, a minus and a minus. And then 3 and 1 would give me 6 minus 1, which is 7. And then just substitute your cosine in there. So if it helps, leave the word cosine out and factor it that way, and then stick it back in there. So I'm really going to solve 2 separate problems. Either this equals 0 or this equals 0. Just to save myself some space, I need to move my 1 over. So 2 cosine of x would equal 1. Divide by my 2, so cosine of x would equal 1/2. Here I'm just going to move my 3 over, so cosine of x equals 3. Now again, on these ones, we're not doing it between the interval. We're going to add the 2k pi on the end, unless we can combine it and shorten it up. So first thing I'm going to do is look for where my cosine of x equals 1/2. Cosine equals 1/2 at pi over 3. And looking down my list, doesn't equal 1/2 again until 5 pi over 3. Looking for where the cosine of x equals 3. If I look down my list, there is not a single one where it equals 3. So I'm going to put in my 2 answers. I'm going to either have pi over 3, since my period of cosine is 2 pi, I'm going to have the 2k pi with k being an element of z, or I'm going to have my other answer, 5 pi over 3 with 2k pi and k being an element of z. So both of those will go in for your solution. If we look at number 11, I need to factor this one. Notice on this one, I can factor out the sine of x. So I'm going to put the sine of x in front. What I would have is 2 sine of x plus 1 equals 0. Again, if it helps, put it as 2x squared plus x and see how you can factor that. That's how that would factor out. So either the sine of x would equal 0, or 2 sine of x is going to equal, I'm going to move my 1 over, so it's going to be negative 1, which means the sine of x equals negative 1/2. And then I'm going to look down my chart. So the sine of x equals 0 at 0, and also at pi. Those two I'm going to be able to combine into an answer then. Sine of x equals negative 1/2. Negative 1/2 would be at 7 pi over 6. And negative 1/2 is also at 11 pi over 6. Those ones I can't combine together. So I'm actually going to have 3 answers. This answer is going to go together. I would say 0 plus k pi, with k being an element of z. But I really don't need the 0 in front of that. So every pi, I'm going to be at 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, so forth. So I don't need the 0. I'm just going to put in k pi with k being an element of z. Or, over here to these two answers. These ones are not 180 degrees apart, and sine has a period of 2 pi. So I'm going to have 7 pi over 6 plus 2k pi with k being an element of z. Or I'm going to have 11 pi over 6 plus my 2k pi, again with k being an element of z. So all three of those are going to go in for your solution. Normally I will have 4, but this one I could combine together. 0 plus k pi, which is just k pi. And then I have my 7 pi over 6 plus 2k pi, and my 11 pi over 6 plus 2k pi. And number 12, this time I'm doing secant. So, factoring that with my two sets of parentheses, secant squared would be secant of x times secant of x. The end is a negative, so 1 plus and 1 minus. I want a minus in the middle, so I'd have to have a minus 2 and a plus 1 to equal my 0. So either the secant of x is going to equal, that will become negative 1 when I move it over, or secant of x, that will be 2 when I move it over. So looking under my secant column for negative 1, at pi, and that's my only answer there, secant of x equals 2. At pi over 3, secant of x equals positive 2. At 5 pi over 3. So again, on this one, I'm going to end up having 3 answers. None of them can be combined. So I'm going to have pi plus 2k pi with k being an element of z. Or I'm going to have pi over 3 plus my 2k pi with k being an element of z. Or I'm going to have 5 pi over 3 plus my 2k pi with k being an element of z. Normally sine, cosine, secant, and cosecant has a period of 2 pi, so that's normally how your answers will be, unless, like I said, for some reason you can combine them, and then you could.